ya está grabando.
Hello, we're Team 3. My name is José Oscar Salazar. The team members are Rocío, Sara, Rodrigo, and Ariana. And our project is called WISE.
Okay, good. The introduction of our project. Our project is called WISE, where it is water irrigation by solar energy. This is a water irrigation system, and it's not a regular water irrigation system. This system uses a humidity sensor. So we have our pot full of soil, and in the corner it has the humidity sensor. So when the humidity levels are low, the system activates. But it also doesn't use just like energy, because energy can contaminate. It uses the solar panel. The solar panel, this solar panel with solar energy that uses like electricity for making our system work. So the water pump will irrigate the plant when the levels are low, and that is what our project is about. So it is self-sustaining. Now we are going to talk more in detail about some aspects of our project.
We have the research question, that is, how can sensor technologies improve the accurate measuring and detecting low humidity levels in the agricultural or industrial environment? We use these questions to develop all the research of our project. Then we have the Sustainable Development Goals that are the one the ONU proposed for the 2030. In our case, we use the SDG number 7, affordable and clean energy, by using solar panels in our prototype, so it can be sustainable and autonomous. We also use the SDG number 11, that are sustainable cities, by implementing our prototype in the communities, which will help to promote the clean energies and also to avoid the waste of water. We have the objectives that are the general, that is to decrease the waste of water while doing a routinary activity such as irrigating the plants. And we have the specific ones that are do not waste energy on basic irrigation system, and to make a more economic way through an auto-sustainable solution or option.
So, in recent years, water waste has become an even more serious issue, especially because of the droughts that have been affecting our state. Many people don't realize how the process of irrigation can waste water. So this problem inspired us to create this project. Our main goal is to reduce the excessive waste of water while still allowing people to get fresh food. By using a more effective way, we can help save this expensive resource. Okay. The main problem that we are addressing is the excessive waste of water while irrigating plants. So, in many gardens, water is wasted because the irrigation system does not adapt to the essential needs of the plant or the condition of the water. While analyzing other solutions that already existed, we realized that most of them rely on very basic mechanisms, like activating them manually or using time sensors. So these can be very useful options, but they don't really adapt to the whole needs of the plant and the condition of the weather and stuff like that. So why our solution is better? Our solution includes a humidity sensor that detects when the soil is dry and activates the irrigation system only when it's necessary. And this sensor also makes the whole process automatic.
Then we have our hypothesis, that is, if the irrigation system will be sustainable and independent by using solar panels, then the sensor will activate the pump only if there is a lack of water, avoiding the waste of water and improving the healthy growth of the plants. The independent variable of our project is the amount of water used by the system or the watering system in general, and the dependent variable would be the level of humidity of the soil.
Okay, methods. Our project is a STEM project. The STEM projects are science, so it has to be systematic. We have three main aspects. The research instrument that we are using are the humidity sensor, because using this we can know how much water we are saving, which is the main hypothesis, the main purpose of doing this project. Our project is an experimental design because we are doing tests. We are testing if our hypothesis is correct by using the humidity sensor to check the levels of humidity of the sun. And well, we have 4 steps that we use to carry out this project. We have identifying the problem with the specifications. So we see that we didn't, well, in Nuevo León there is a lot of lack of water and also contamination. That's what we identified. And step 2, the research on the materials, where we had to investigate what is a humidity sensor, how it works, the solar panels also, the materials, what we need to create our irrigation system. And step 3, we have testing, which was already doing the prototype and testing if the sensor works and if it's saving water. And step 4 was data analysis, with comparing it to other irrigation systems that doesn't use humidity sensor.
After experiment with different variables, after elaborating the product, we made experiment with 3 different variables. One, when you irrigate water with an intuitive way, and the other one is measuring it with a syringe, and the other one using our product wise. Our results was that with intuitive way, the regularity will be low because you wouldn't be irrigating the exact same amount of water. The adaptability will be high because you will see exactly where you're irrigating. Risk of error will be also high because you don't know if it's going to draw. The waste of water will be also high because a lot of people only just drop the water there, and the waste of time will be medium because you have to irrigate water manually. With a measured syringe, the regularity will be high because you will irrigate the same amount of water always. The adaptability will be low because it will be the same amount of water no matter what are the external factors. Risk of error will be medium because it will be the same amount of water. The waste of water will be moderate, and the waste of time will be high because you will measure the water, then irrigate it with a syringe, etc. And with the project wise, everything will be like the best expected. The regularity will be high, the adaptability will be high because it also regulates external factors such as rain. The risk of error will be low, except with an exception of maintenance errors. Waste of water will be the minimum one, and waste of time will be low because you only will need to turn on the product. The process of making was a little bit difficult. Here you see our blueprint, just say like that. First, we assembled almost all of the components, but we were missing a piece. We tried to assemble all of it without that piece. It didn't work, so we need to buy that piece. After we bought the piece, it worked. So yeah.
It did work. I want to see it, okay? Oh, that's beautiful. You have solar panels. That is pricey.
Here you will see how it's irrigating because the soil is dry.
Love it, boys. Okay. Questions?
Okay, now the questions from ICT. We need to cover the ICT questions, the definite questions. The first one, for the problem raised, can robotics be applied as an area of improvement? Yes, they can, because robotics can help automate this process. For example, where you need to harvest the crops or plant new ones, you can have a robot do it for you. Well, of course, that will be more advanced, but in a probably near future, we can do that. And then the 2 questions from DPA. Did your mathematical results help confirm or reject your hypothesis? Yes, it did. The results that we were expecting were proven and allowed us to check them mathematically. The next one, the last question. What would be it's okay, teacher. What would be your conclusion about the mathematical results contributed to confirm or reject your hypothesis? Our conclusion is that the numerical data that we thought was correct, and it confirmed our hypothesis. The conclusion. Well, doing the project was a bit difficult. We had a couple of problems, but we solved them, and they helped us improve our design bit by bit. And yeah, that's pretty much it. We learned a
And I
lot
guess
about.
you kind of developed the problem solving skills,
Yeah.
creativity, and all of that because that would take like pretty much a lot of not only just don't talk about the money, about the effort and the science and the sleepless night that you might have probably gone through it. Okay, discussion. What's the discussion here? Was your hypothesis correct?
Yes, it was. All the data that we accumulated it from the results proved our hypothesis was correct. Also, all the mathematical operations were correct.
Expected. Okay.
Yes, it meet our expected results. Basically.
Be very expected results. Okay. So you're still on the struggle. Okay, very good. Excellent job, guys. Well,
Thank you,
what
teacher.
expect you're gonna demonstrate it to me?
No, because if we turn it on, it may throw water all over the floor.
I didn't shower
Yeah.
today.
But as you can see, we were on water. I think it was some noise.
I got the 24
Y los vamos a olvidar, ¿no?
Una epifanía es una manifestación de una cosa.
Ah, con razón.
I got an epiphany.
Shall we put it outside or we leave it here by
Técnicamente, pero no creo que digan. Tengo la epifanía.
Okay, thank you.
¿Cómo dices?
Let me give you the feedback. Claps to team number 3.